Hello student, again welcome you in our YouTube channel Alpha Classes and myself Zinc. So today we will do some NCERT in text question. So we have a NCERT in text question. Uh, so the look at the board, and we have a first NCERT in text question. Question is, classify the following solids in different categories based on the nature of intermolecular forces operating in them. ये सारे हम ये जो ये सारी चीजें दे रखी हैं हमें 1 2 3 4 5 6 7 8 9 10 11 आपको सॉलिड्स दे रखे हैं और उनको आपको क्लासिफाई करना है डिपेंड based on the nature of intermolecular forces. ये जो सॉलिड्स हमें गिवन है इनके बीच में किस तरह का फोर्स ऑफ अट्रैक्शन है उस बेसिस पे हमको क्या करना है, इनको क्लासिफाई करना है. सो लेट्स गेट स्टार्टेड. सो फर्स्ट ऑफ ऑल वी ऑब्जर्व दिस फर्स्ट सॉलिड पोटेशियम सल्फेट फॉर्मूला इज K2SO4. K2SO4 is the formula of potassium sulfate, K2SO4. So in this solid we all know that it has two components, two radicals. First is K plus and second one is SO4 2 minus. So one is positive and another is negative. So this is the cation and this is anion. And this phenomena under in which type of solid? Ionic solids. Ionic solids. So first solid in under ionic solid. Second one is, so this is the ionic solid because it has a two component cation and anion, and force of attraction apply in these two components, that is electrostatic force. Which force applied between cation and anion? So force is electrostatic force. Electrostatic force between cation and anion. We talk about tin. So tin is a metal, we all know that. So this is a metallic solid. And if we talk about force of attraction in metallic solid, so we all know that force of attraction is metallic force of attraction. Metallic force applied in metallic solids, attraction. And there are two components. First is kernel and second one is C of delocalized electron. Delocalized electrons, and we can say mobile electrons. C of delocalized electrons. These two components in metallic solids, they create metallic force in metallic solids. Further, and this is ionic solid. Second is metallic solid. If we talk about benzene, formula is C6H6. C6H6, benzene. So benzene is molecular solid. Molecular solid. And in molecular solid, they are non-polar. Benzene is non-polar molecular solid. If we talk about urea, so urea formula is NH2CONH2. So formula of urea is NH2CONH2. NH2CONH2. And urea is which type of solid? So urea is molecular solid. But urea polar solids, polar molecular solid. Polar. We can write polar. Polar solid. Urea is polar solid, polar molecular solid. And if we talk about ammonia, fourth one, first is ionic solid, second is metallic solid, third is benzene. Benzene is molecular solid, but in under is non-polar. Non-polar means if we have a molecular solid, we have a molecular non-polar solid, so component between components, force applied force between components between molecular solids. So force of attraction is dispersion force. We talk about in previous lecture. Dispersion forces, or we can say London forces. Non-polar means two component has same electronegativity, so they consider as a non-polar. And we talk about polar, so in polar component have different electronegativity, so they show polarity. If we talk about ammonia also molecular solid. NH3 is molecular solid, molecular solids as well as polar. It also polar. Urea and ammonia, they are both are molecular solid, polar molecular solid. Ammonia and water. If we talk about zinc sulfide, so formula is zinc sulfide, ZNS. So if we observe this formula, so we get zinc plus and S2 minus. So this is Ni and this is cation. Zinc ion, and this is sulfide ion. Sulfide ion. So in zinc sulfide there are two components. First is there are two components and they both are ions. So force of attraction between these two ions. So force of attraction is electrostatic force. Electrostatic force. So if force exists, electrostatic force, so these solids can write ionic solid, because in ionic solids component just work as a ions. If we talk about graphite, so graphite is a covalent solid. Covalent solids. Graphite. We discussed in previous video lectures, graphite and diamond are the most covalent solids, most popular molecular covalent solid. So graphite is covalent solid. If we talk about rubidium, so rubidium is metal. So force of attraction between in metallic solid. So force of attraction is, we talk about metallic force of attraction between kernels and CO delocalized electrons. So here these are metallic solids and these are metallic solids. If we talk about argon, so argon is molecular solid. Argon is molecular solids. Molecular solid. But in molecular solids, it is non-polar molecular solid. If we talk about silicon carbide, so silicon carbide, because in this matter, in this carbon is most, so silicon carbide also covalent solid. Silicon carbide also covalent solid. And water, ammonia and urea, they are all molecular solids, polar molecular solids. Benzene and argon, non-polar molecular solids. Silicon carbide and graphite, both are covalent solids. Potassium sulfate and zinc sulfide, they both are ionic solids. And these tin and rubidium are the metallic solids. So this is the 1.5 question number 1.5. So we further go ahead. Next question. So next question is So next question is solid A 1.6. Solid A is a very hard electrical insulator. Solid A is a very hard electrical insulator in solid as well as in molten state. And melts at extremely high temperature, very high temperature. What type of solid is it? What type of solid is it? So this is the next question, and question is solid A is a very hard electrical insulator. These points in solids as well as in molten state and melts at extremely high temperature. So there are three things which is very important in this question. So solid A is a solid. Let's suppose solid A is a solid, and this solid some property exists in question. So first property is this, and second property is this. There are two properties, and we focus these two properties, and finally we get answer if we observe these two properties. So first is very hard electrical insulators in solid as well as molten state. If we remember a type of crystalline solids, that is covalent solids, one of the important solid, covalent solids. So in these two properties we discussed previous video lecture. These two properties match in covalent solids. They are very bad conductor in solids as well as molten state. Both situation they are very bad conductor, and we can say they are highly electrical insulator, very hard and extremely high temperature. Second thing is extremely high temperature, means boiling point very high. Boiling point, covalent solid, boiling point very high, very high. Because क्या वजह क्या है, कारण क्या है? In this situation, what is the reason? So reason is, in covalent solids, force of attraction या another चीज होती है इसमें, because they bind, या कह सकते हैं they bind with each other, या कहते हैं their component bind with each other, covalent bond में सिंगल बॉन्ड भी आ जाएगा, सिंगल बॉन्ड, डबल बॉन्ड भी आ सकता है, शेयरिंग इलेक्ट्रॉन, सिंगल बॉन्ड, डबल बॉन्ड, also triple bond. Covalent bond, each other covalent bond, which is very high, which is very high strength. बहुत सारी बातें लिख सकते हैं इसमें, लेकिन मेन चीज ये है कि इसके जो कोवेलेंट सॉलिड्स हैं उनके बीच में जो उनके जो कंपोनेंट होते हैं उनके बीच में जो फोर्स ऑफ अट्रैक्शन होता है, या हम कह सकते हैं कोवेलेंट बॉन्ड होता है, वो क्या होता है, वेरी हाई। सिंगल बॉन्ड होगा तो कम, क्या होगा, लेस इसका क्या होगा, वैलेंट बॉन्ड होगा। डबल बॉन्ड होगा तो इसका मोर हो जाएगा, मतलब और बढ़ जाएगा इसका क्या, बॉइलिंग बॉन्ड, क्योंकि दो बॉन्ड बनेंगे तो इनको तोड़ने के लिए एनर्जी की ज़्यादा जरूरत पड़ेगी, मतलब बॉइलिंग पॉइंट क्या हो जाएगा, हाई हो जाएगा। अगर ट्रिपल बॉन्ड मिल जाएगा तो और ज़्यादा हाई हो जाएगा। तो डिपेंड ऑन द कोवेलेंट बॉन्ड। सो आंसर इज कोवेलेंट सॉलिड। सो दीज टू प्रॉपर्टीज under या occur in covalent solids. So we talk about next question. So next question is 1.7. Ionic solids conduct electricity in molten state. But not in solid state experiment. देखो कितना प्यारा क्वेश्चन है और बहुत ही इजी क्वेश्चन है, वेरी इजी क्वेश्चन इज आयनिक सॉलिड्स कंडक्ट इलेक्ट्रिसिटी। कौन सी सिटी, इलेक्ट्रिसिटी। आयनिक सॉलिड कंडक्ट इलेक्ट्रिसिटी इन मोल्टन स्टेट, पिघली हुई अवस्था में, मोल्टन स्टेट, बट नॉट कंडक्ट इलेक्ट्रिसिटी इन सॉलिड स्टेट, मतलब कठोर अवस्था, ठोस अवस्था में। चलिए, so we all know that first of all we talk about ionic solid. ionic solid component. In ionic solid there are two components या और भी क्या है constituent particle is ions. आयन्स ही तो होते हैं आयनिक सॉलिड्स में, आयन्स होते हैं. अब we all know that if ions freely move, so they conduct electricity very well. If ions not move easily, so they conduct electricity poorly. मतलब आयंस का होंगे हमारे अगर फ्रीली मूव करने के लिए वो फ्री है तो इलेक्ट्रिसिटी कंडक्ट कर सकते हैं. वो क्या करते हैं, चार्ज को कैरी कर सकते हैं, कैरियर्स होते हैं. तो इलेक्ट्रिसिटी क्या हो जाती है, कंडक्ट हो जाएगी. अगर हमारा चार्ज क्या है, बंधा हुआ है या रुका हुआ है, तो वहां पर क्या होगा, इलेक्ट्रिसिटी डज नॉट कंडक्ट. चलिए अब इसको लिखते हैं कि क्या एकदम एग्जैक्ट लिखना होगा. चलिए आयनिक सॉलिड कंडक्ट इलेक्ट्रिसिटी इन मोल्टन स्टेट. तो पहले लिखते हैं आयनिक सॉलिड कंडक्ट इलेक्ट्रिसिटी इन मोल्टन स्टेट बिकॉज आयनिक सॉलिड आंसर आयनिक सॉलिड्स कंडक्ट electricity in molten state because ions freely moves in ionic solids conduct electricity in molten state because ions freely move in solution with gaseous solution. They carry charges one place to another hence electricity produced. Ionic solid conduct electricity in molten state because ions freely moves, free move कर सकते हैं उनके बीच में molten state. In molten state we can also add one thing is electrostatic force. Ionic solid conduct electricity in molten state because ions freely moves in solution because they have low या weak electrostatic force. They have weak electrostatic force. सिंपली जब आयंस मूव कर सकते हैं तो मींस उनके बीच में जो इलेक्ट्रोस्टैटिक फोर्स है वो क्या वीक हो चुका है, इस वजह से क्या कर सकते हैं, मूव कर सकते हैं. अगर चार्जेस एक जगह से दूसरी जगह मूव कर सकता है तो मींस इलेक्ट्रिसिटी का हो सकती है, कंडक्ट हो सकती है अच्छी तरह से. तो आंसर इज दिस. बट इन सॉलिड स्टेट बिकॉज सॉलिड स्टेट ions does not freely move and that's why the force of attraction between ions in solid state very high. That's why they does not carry charges one place to another and hence electricity does not produce in solid state. So answer is this. So today we have been some questions. सो अगले वीडियो लेक्चर में हम एक नया टॉपिक, एक नए क्वेश्चन लेके आएंगे, तो उसको हम देखेंगे। आगे के जो वीडियो लेक्चर रहेगा जहाँ तक क्रिस्टल लैटिस के बारे में बात करेंगे, यूनिट सेल के बारे में फर्दर वीडियोज रहेंगे। तो तब तक के लिए हमारे चैनल के साथ बने रहिए, और ये अगर आपको वीडियो अच्छा लगा तो उसको लाइक कीजिए और इसको ज़्यादा से ज़्यादा शेयर कीजिए। थैंक यू वेरी मच।